Dear students, very good morning. Chapter 2 Polynomials. One lecture is attended by you. Today, lecture number 2. Understood? Already you know that you have government evaluation test, state evaluation test on date 17 and 18. 27 and 28. In science portion, how many chapters are there? 4 chapters. 1, 6, 10 and 15. As far as 1, 6, 10 is concerned, you already got the video lectures. You are explained those chapters. The remaining is only one chapter. That is chapter number 15, Environment. In 2 lectures, the chapter was completed. You are sent 2 lectures along with PDF. Okay? So you need to prepare thoroughly for government evaluation test. Okay? એટલે જે કંઈ પણ whatever homework I send, okay, regarding maths, એ easily complete થઈ જાય એવો homework હશે. એમાં થોડો ટાઈમ ભલે લેસ સ્પેર કરો, પણ સ્પેર મોર ટાઈમ ફોર પ્રિપેરેશન ઓફ evaluation test to be taken by government. Today, in lecture number 2, we are continuing the same topic, that is zeros of polynomial. Same topic continues. Last time we practiced some of the example regarding zeros of polynomial. Today, in lecture number 2, we are going to solve 4 examples, and that will give you an idea how to find zeros of polynomial. Last time we have selected all example where you have to find addition of the factor, if you can remember. Today in lectures there are some different polynomial. Okay, suppose first example, if you take, if you are given such polynomial x square, suppose I write plus 3x minus suppose 10. How to find the zeros of such polynomial? First, as usual, you will write let p of x equal to 0. If in exam name of the polynomial hasn't been mentioned, you should take p of x. Therefore, x square plus 3x minus 10 equal to 0. Here there is no coefficient, so 1, and always you multiply first coefficient with last term. 1 10 ja 10. Now the logic. Such factor of 10 whose subtraction is 3, obviously. Suppose anybody asks you find the factor of 10, so 10 1 ja 5 2 ja. As you know, 5 2 ja 10 and 5 minus 2 3, because you have to take subtraction of both the factor. One has to be positive, one has to be negative. 2 factors which you thought 5 and 2. 5 is a greater factor, 2 is a smaller factor. So out of the 2 factor, greater factor must have this sign, and rest opposite sign. So you can write this way. Here I will write plus 5x minus 2x minus 10. See, greater factor sign is similar to this term and this one opposite sign, therefore x common. How to take out common, you know, x plus 5. Here because here is minus sign, minus 2 common, x plus 5 equal to 0. When you take out minus common, sign change take place. X plus 5 common bracket, x minus 2 equal to 0. X plus 5 equal to 0 or x minus 2 equal to 0. X equal to minus 5, x equal to 2. Finally, after you get this, you will write your answer that the zeros of polynomial are that you have to write. I am not writing the statement, but you need to write what zeros of polynomial are minus 5 and 2. First you watch the sum, understand? Watch very carefully before we go to another example. First you have to understand this properly. Okay? Let us go for another example. First one we have solved, that is regarding quadratic polynomial. Okay? Now suppose another example we take. Suppose it is like suppose, let me take the second example, p of x equal to, suppose you are given like this, 3x square minus x minus 10. So how will you solve this example? First, as you know, you will write let p of x equal to 0. Then you will write this way, 3x square minus x minus 10 equal to 0. Multiply first term and last term, 3 tens are 30. Now just roll your pen. 3 tens are 30. Such factor of 30 whose subtraction is 1. Nothing is here, so we have to accept as 1. Understand how you got 30? 3 tens are 30. Means you are finding the factor of 30 whose subtraction is 1. Obviously 5 6 ja. 6 is a greater factor, so it will be here and here smaller. So 3x square minus 6x. Because you take this minus, this is plus. Take out common. What is common from first two term? 3x common. X, 3 2 ja 6. Okay. Here is plus sign, 5 common, x minus 2 equal to 0. Therefore, x minus 2 into 3x plus 5 equal to 0. X minus 2 equal to 0 or 3x plus 5 equal to 0. Therefore, x equal to 2, and here directly first 3x equal to minus 5, then x equal to minus 5 upon 3. We got the zeros. You have to write in the end what the zeros are, 2 and minus 5 upon 3. Every now and then when you find zeros of polynomial, you have to be very watchful regarding this. Understood? Okay. Verify the second example. Let us take one more example to find zeros of polynomial. Understood? One more example. Suppose, third one, let us select q of x equal to x square minus 3. First step, as you know, let q of x equal to 0. Then you will write x square minus 3 equal to 0. Now because here are only two terms, we cannot apply the splitting term method, but because there are two terms and in between the two terms there is negative sign, we have to adopt that method of difference of perfect square. What is that? A square minus b square equal to a plus b into a minus b. Square root of x is x. Because this is not a perfect square number, its square root is under root 3 whole square equal to 0. You got a square minus b square, so one time plus, one time minus. Whenever such number you come across which are not perfect square, you have to write them under root. Okay. So x plus under root 3 equal to 0, or x minus under root 3 equal to 0. X equal to minus under root 3, x equal to under root 3. You got the roots of quadratic polynomial. This one are minus under root 3 and under root 3. Understood? So this is the way you can find, and as far as quadratic polynomial is concerned, you need to remember two methods. If polynomial contains three terms, one of x square, x constant, you have to always follow the splitting term method which we understood in previous example. But whenever you come across such polynomial which has only two terms, so you have to adopt this method, taking one time plus, one time minus. Okay. Now another example, still we take one more regarding cubical polynomial. Okay, in cubical polynomial, suppose we take one example. Suppose in exam you are asked x cube minus 4x. This is already a cubic polynomial because degree is 3. First step, as you know, r of x equal to 0. X cube minus 4x equal to 0. In such cubical polynomial, always develop one method of taking common. We take x as common. What is left? X square minus 4 equal to 0. Let us compare x equal to 0 or x square minus 4 equal to 0. This is not further factorizable. It is to be kept as it is, but here still this polynomial is factorizable by the method of a square minus b square. This I just have to carry till the end. Minus 2 whole square equal to 0. Okay. X equal to 0, and here x plus 2, x minus 2 equal to 0. X equal to 0 we have to keep here x plus 2 equal to 0 or x minus 2 equal to 0. Therefore x equal to 0, x equal to minus 2, x equal to 2. So you got the polynomial has 3 zeros here. Because it is already which type of polynomial? cubic polynomial. Okay, that's why it always have 3 zeros. Here you got 3 values of x, particularly x equal to 0, you got x equal to -2, and you got x equal to 2. 3 values, because cubic polynomial has how many zeros? 3 zeros, and it intersect x-axis at how many points? 3 points. That we discussed in our lecture number 1. Okay, so actually in textbook there is no way, even in exercise given, to find the zeros of polynomial, but we can find zeros of polynomial this way. It can be possible to find. Understood? So always whenever you come across such example where you have to find zeros of polynomial and it is a cubical polynomial, always develop a method of taking out common. It is compulsory. Once you take out common, then the sum becomes very easy for you to factorize it. Understood? But taking out common is a must. Okay? So that way you have to be very conscious regarding this. Suppose if you no doubt in one more extra lecture we are going to understand graphical presentation of all polynomial. That will be next lecture, but in 2 lectures, lecture 1 and 2, we just want to give it only for one concept, that is how to find zeros of polynomial. But regarding zeros and other examples, okay, that we'll solve later. Understood? So suppose any polynomial you are given of this type. Understood? It can be factorized in this way, right? So you need to understand whenever you are asked in exam, as per the board pattern, in 2 marks, where you have to find zeros of polynomial. It can be quadratic polynomial, it can be cubical polynomial. Whenever you come across cubical polynomial, and in cubical polynomial also we know the standard form already. Actually, what is the standard form that you know? That if it is a cubical polynomial, the real standard form is this: ax cube plus bx square plus cx plus d. But sometime it happens that polynomial may just consist of 2 terms only. Understand? But to call it a cubic polynomial, this is sufficient, that polynomial needs to have one term. Understand? Having third power of x, that is sufficient for naming it a cubical polynomial. So that you have to keep in mind. You understood this? Okay? So dear student, in lecture number 1, I discussed some detail regarding the graphs of linear polynomial, quadratic polynomial, cubic polynomial. Then we started solving in lecture number 1 some examples of zeros of polynomial already. And in today's lecture also we continued the same topic to find zeros of polynomial. Understood? Rest of the topic we will discuss in our next lecture. Okay? Thank you very much.